The longest common subsequence problem is about finding the longest sequence that appears in two texts in the same order. It doesn't have to be consecutive, just the same order. We can solve this using dynamic programming. Let's solve with this example. First, we define two-dimension table. We fill the first row and the first column with zeros. Now we're ready to start. The idea is simple. We go through the table and compare corresponding characters. If the characters match, we take the diagonal value from the top left, plus 1, and place it in the current cell. This means we found one more matching character. For this case, diagonal value is 0, so we set current place 1. If the characters don't match, we take the larger value from either the left or the top cell. Since 1 is bigger, place 1. Rest of the row, we keep 1. Now we move on to the second character. Here the values don't match, so we just take the maximum from the left or the top. That keeps the value as 1. Now this is the interesting part. You can see the characters match again. When they match, we take the diagonal value from the top left and add 1. That gives us 2. And we keep going in the same manner. Next, we start filling the row with Y. Step by step, we apply the same rule. Match means diagonal plus 1. No match means take the max of left or top. We continue the same way for the last row. Eventually, the table is filled, and the very last cell gives us the answer. In this case, the length of the longest common subsequence is 3. But what if we want the actual subsequence, not just the length? For that, we backtrack from the last cell. If the characters match, that means the character is part of the subsequence, so we move diagonally. If they don't match, we move in the direction of the larger value, either up or left. We continue this process until we reach the first row or the first column. Now, let's look at the code. Here we loop through both strings, build the DP table, and apply the same rules. And that's how we solve the longest common subsequence problem using dynamic programming. Thank you for watching, and don't forget to like and subscribe for more algorithm explanations.